find surface area, we're literally just finding the area of each surface of a three-dimensional figure. For a pyramid, pyramids have one base. So if we're finding the surface area, you're going to find the area of that one base. I'll use capital B for base. And the base for a pyramid is any type of polygon. So we find the area of the base. So in this case, our base would be, looks like a square. And then we'd find the lateral area, or the area of all of the lateral faces. For a pyramid, those lateral faces are triangles. So area of the lateral faces. For a pyramid, those lateral faces are triangles. So if we have a square base, then we have 4 lateral faces, or 4 triangles, one for each side of my square. If it was a pentagonal pyramid and the base was a pentagon, there would be 5 triangles. If it was a hexagonal pyramid, there would be 6 triangles, or a triangular pyramid would have 3 triangles for the lateral faces. So the surface area in total, you have all of those lateral faces, which are triangles, plus the area of the base. For a cone, the base is always a circle. So if we're finding the area of the base, you're always going to use pi r squared, because that's how we find the area of a circle. And then to find the lateral area, you use this formula, pi r l. That's your lateral area. So it's really the same as a pyramid, but instead of the base being a polygon, it's a circle. One thing to note is this L stands for slant height. Pyramids and cones have 2 types of heights. They have the height, which makes a right angle with the center of the base. And they have the slant height, which is the height of the side. So when it says L, we're talking about the slant height. If it said H, we'd be talking about the height. We use slant height when we're finding surface area, and the height when we're finding volume, which we'll get to later. So same thing with pyramids. The height goes to the middle of the base. The slant height makes a right angle with the edge of the base. Let's do our first example. This is a square pyramid. Because it's a square pyramid, we have to find the area of 5 surfaces. We have the base, plus the lateral area is made up of 4 triangles, all of which are the same size. So when we're finding the area of the base, that's what big B stands for. We're finding the area of the square. In this case, our square is 2 by 2, so the area of the base is 4. And when we're finding the lateral area, we're finding the area of each one of those triangles. So 1/2 base times height of the triangle. The base of a triangle is this distance, so 2. And the height of the triangle, we use the slant height, is the height of the lateral face. So 3 is the height of that triangle. So we have 1/2 of 2 times 3. And there are 4 triangles, so I'm going to multiply that answer by 4 to get the lateral area. So my lateral area is, 12. If I multiply all of this out, 1/2 of 2 times 3 is 3, times 4 is 12. My whole surface area is 16 feet squared. But again, my lateral area, I asked for lateral area also. My lateral area was 12 feet squared. So lateral area, the area of all the triangles. Surface area is the area of all the triangles plus the area of the base. Here's another example, but in words. We have another square pyramid. I'm going to go ahead and draw that. It tells me, I'm terrible at drawing these. You'll just have to do your best visualizing. It tells us that the pyramid itself has a height of 15. So that's not the slant height. That's saying from the top of the pyramid to the middle of the base is 15. That is not the height that we want when we're calculating surface area. And it tells us that the base edges are 16. So this is 16, this is 16. So let's start by finding the lateral area of this square pyramid. So lateral area, our lateral faces are triangles. There are 4 triangles. So we're going to be using 1/2 base times height. The tricky part here is we don't know the height of the triangle. We know the base of each one of these faces. The base of each face is 16. Right? There's one triangle, the base is 16. But we don't know the height because the height is what goes along the edge. We know the height of the whole pyramid is 15, but we don't know the height of that triangle. So to find the height of that triangle, I'm going to redraw that right triangle that's created right there, where the height of the pyramid is 15. We're looking for the slant height, or L, because that's the height of the triangle. And this little piece right here, if I'm taking out this triangle, I know this is getting messier and messier, but that was 8 because it's half of 16. So I could use this and do the Pythagorean theorem, 8 squared plus 15 squared equals L squared, to find that my slant height is 17. So the height of the triangle is 17. Just keep in mind, whenever you're doing surface area, you're going to want the slant height, and whenever you're doing volume, that's when we use the height. So if you know the height and you need slant height, use the Pythagorean theorem. If you know the slant height and you need the height, use the Pythagorean theorem. So the area of one triangle, one of the lateral faces, is 1/2 of 16 times 17, and that is 136 centimeters squared. And we want 4 of those. So my whole lateral area would be 544 centimeters squared. That's the lateral area, the area of the 4 triangles. So the area of one triangle was 136. There were 4 of them. So we multiplied by 4. So now we need to find the area of the whole surface. So surface area is the lateral area plus the area of the base. The area of the base is the area of the square. That's much easier to find. It's a 16 by 16 square, which is 256 centimeters squared. So we're going to take 544 plus 256 to get the surface area is 800 centimeters squared. Let's do some more examples. So here we getting a little bit more interesting. We have a hexagonal pyramid. We're going to find the lateral area and the surface area. Let's start with the lateral area. So lateral area again, not 4 this time. This time it's a hexagonal pyramid, so there are 6 triangles, 6 lateral faces. So let's find the area of one triangle. The area of a triangle is 1/2 base times height, and the height of the triangle is the slant height. So our slant height is 14, so that's the height of the triangle. The base of each one of these triangles is 10, because that's the side length of the hexagon. And if I take 1/2 of 10 times 14, that means the area of one triangle is 70. So if the area of one triangle is 70, the lateral area, there are 6 of those triangles. So 6 times 70 is 420 feet squared. That's my lateral area. Now for surface area. So I need to find the area of the base now to do surface area. Our base is a hexagon, and to find the area of a regular hexagon, we use 1/2 apothem times perimeter. And it does tell us what the apothem is. The apothem is 5√3 And it doesn't tell us the perimeter, but we know each side length is 10. There are 6 sides, so the perimeter must be 60. So if I multiply all of that out, I get that the area of the base is about 261. So lastly, when I put it all together, my surface area is the lateral area plus the area of the base. So 420 plus 261. So our surface area is about 681 feet squared. All right, we've got a pentagonal pyramid this time. So there are 5 triangles for my lateral faces. So when I'm finding my lateral area, there are 5 triangles. Let's go ahead and start by finding the area of one triangle. Do I know the height of the triangle? I do not. So first step is we need to find the height of the triangle, or the slant height. So we're going to take out this right triangle that's right here, where I know the height of the whole pyramid is 4.8. It gives me the apothem, 5.5, and I'm going to use the Pythagorean theorem to find the slant height. So when I do that, when I use the Pythagorean theorem, I get that the slant height is about 7.3, which means the height of each triangle is about 7.3. I'm going to plug in the rest of my information here for my triangle. The base of each triangle is 8. So if I take 1/2 of 8 times 7.3, get about 29.2. And there are 5 triangles, so I'm going to take 29.2 times 5 and get about 146 meters squared. So my lateral area is 146 meters squared. For my surface area, I need to know the area of the base as well. So let's find the area of the base, which is a pentagon. And to find the area of a pentagon, we use 1/2 apothem times perimeter. It did tell us the apothem is 5.5. We don't have to find that. And we can calculate that the perimeter is 8. Each side length is 8 times 5, which is 40. So the area of the base would be 110. Now we can put it all together. My surface area is the lateral area, the area of all the triangles, plus the area of the pentagon, the base. So 146 plus 110. My surface area is 256 meters squared. All right, let's do a couple cones now. So cones are nice and convenient because we know from a cone there is a formula. Because the base is always a circle, to find the area of the base, we're always going to use pi r squared. And the lateral area always looks the same. And to find the area of it, it's pi r l. So when I'm going to find my lateral area, I'll start with that. I need pi times the radius, which is 6, times the slant height, which we don't know here. So we are going to have to take a second and find the slant height of this cone. We have a right triangle created by the height, which is 8, and the radius, which is 6. If I use the Pythagorean theorem, I get that the slant height is 10. So my lateral area on this one is 30 pi. Or sorry, 60 pi. And I'm just going to leave it in terms of pi. So my lateral area is 60 pi meters squared. Now I'm going to find the area of the base, the circle, pi r squared. The area of the base is 36 pi. So to find my surface area, I take the lateral area plus the area of the base, 60 pi plus 36 pi, to get 96 pi. So lateral area was 60 pi meters squared. The entire surface area, so including the circle base, is 96 pi meters squared. And I leave it in terms of pi because that is an exact answer. And whenever possible, I like to leave my answer exact. So now let's do a couple of composite figures to end. Composite figures are when you have multiple three-dimensional figures stacked on top of each other. So in this case, I have a pyramid on top of a square pyramid, to be exact, on top of a rectangular prism. So when we're finding the surface area, you only find the area of the surfaces we can touch. So what we do not need to include is this this square right here, where the pyramid meets the rectangular prism. We do not need to find the area of that piece. So do not start by finding the surface area of the pyramid, finding the entire surface area of the prism, and then adding them together, because we do not want to include the surfaces that are being covered. So instead, what makes up of our surface area, I just like to think of it piece by piece. So I'm going to start with the pyramid. So in the pyramid, what we see are 4 triangles, and all of these triangles are the same size, which is convenient for us. So the pyramid is made up of 4 triangles. To find the area of one triangle, we take 1/2 base times height. Our base is 10. The height of each one of those triangles, it tells us, is 12. That's the slant height. That's what we want. And 1/2 of 10 times 12 is 60. So the area of one triangle is 60. So the area of 4 triangles is 240. So that's the pyramid. That's everything that's included in the pyramid. So hang on to that number. Now let's talk about everything that's included with the prism. The prism has 5 surfaces that are exposed. We have the back rectangle back here. That back rectangle is 10 by 32. We have this right rectangle, which is also 10 by 32. We have the left rectangle, which is also 10 by 32, and the front rectangle, which is also 10 by 32. So there are 4 rectangles that are 10 by 32. They will not always be the same size with prisms, so do be careful about that. But the area of one rectangle is 320, and there are 4 of them, so we need to take 4 times 320 to get 1280. And then we can't forget this little square that's also exposed. So we also have a square down there that's 10 by 10, or 100. And now we're going to add up all of those pieces together. So to find the surface area, we add up the area of all the surfaces. So we have 240 plus 1280 plus 100. So our total surface area would be 1620 feet squared. I'm going to do one more example. This one's a little trickier. We've got 3 different shapes here. We've got the left cone. So left cone, I'm going to have to find the cylinder, and we also have a right cone. So let's start with the left cone. What's being exposed on the left cone, notice the circles are being covered up, right? If you had this in real life, you would not be able to touch those circles. The circles of the cylinder are covered up by the cones, and likewise, The cone circles are being covered up by the cylinder. So you would not be able to touch those. Do not include those circles when finding the surface area. So when we're looking on the left cone, this one over here, we only want to find the lateral area because that's the only part of the cone that's exposed. And to find the lateral area of a cone, we use pi r L. And the radius of that cone over there is 2 because it's the same size as this one over here. The radius is 2, and the slant height it gives us is 3. So the total surface area for that left cone is 6 pi. I'll leave it in terms of pi for now. Now let's do the cylinder, what's in the middle. The cylinder, the part that's exposed, is again just the lateral area because the two bases of the cylinder are being covered. So to find the lateral area of a cylinder, we use 2 pi r h. We know that the radius is 2, and the height of that cylinder, it tells us, is 3. So the lateral area of that cylinder, the total surface area of that cylinder, is 12 pi. Lastly, we're going to look at the right cone. The right cone, the base is covered. So we just need to find the lateral area of that right cone. To find the lateral area of a cone, we already did this previously. It's pi RL, but this cone is a different size than the first one. The radius is still 2, but the slant height is 4. So the lateral area is 8 pi. So to find the total surface area, we're going to add up all of the pieces to get 26 pi. Because each one was in terms of pi, I'm just going to leave my final answer in terms of pi.